Hello students, I welcome you all once again back to my channel, that is Mary Afia. Those are watching for the first time, please subscribe to my channel, that is Mary Afia, where you can find many topics from chemistry. Okay, so today in this video I'm going to teach you how to derive an expression for work done in an adiabatic process. Okay, so previously a few days ago I have uploaded a video in which we have learned how to show PV power gamma is equal to constant in an adiabatic process and TV power gamma minus 1 is equal to constant in the adiabatic process. There we have not derived the expression for W. Okay, so this is actually continuation of that video. So carefully take your notebook and put the side heading as derive an expression for work done in an adiabatic process. Put the side heading and underline, students. Are you all ready? Derive an expression for work done in an adiabatic process. So students, from the previous video where we have learned PV power gamma is equal to constant, that gamma is nothing but adiabatic index. So this will be different for different gases. So to start with, please write down, we know that PV power gamma is equal to constant, where gamma is nothing but adiabatic index. Okay. This constant, I can write it as K. Generally constant we will be using K. You all know that, students. So PV power gamma is equal to K. Okay. Now P is equal to K upon V to the power gamma. So it is now in the denominator. If you bring it to the numerator, this V power gamma becomes V power minus gamma. Okay. So this first step, is it clear? Next, below write down, we also know that there is a formula for basic formula for W, students, that is PdV. Okay, P into dV. Now take this equation and integrate on the right hand side within the limits V1 and V2. So this is the adiabatic expansion. So here we assume that the gas expands through a small volume from V1 to V2. So therefore we will integrate this equation within the limits V1 and V2 on right hand side. So what do we get after integration? So look here, W is equal to PdV. Now we are integrating on right hand side. So how to do that? W is equal to integral P into dV within the limits V1 to V2. Written, W is equal to integral P into dV within the limits V1 to V2. But from here we have P is equal to K into V to the power minus gamma. Write down. But P is equal to K into V to the power minus gamma. So what we will do, students, with this P value? We will substitute this P value in this equation. Instead of P, we will write down K into V power gamma. You all know that K is a constant. So a constant cannot be integrated. So how to write the next step? So look at the next step, students. W is equal to K, I am writing it outside, integral V to the power minus gamma, and what is left here? dV. So into dV within the limits V1 to V2. Okay. Now this integral V to the power minus gamma into dV is in the form of a mathematical expression, integral x to the power n into dx. So whose solution is x to the power n plus 1 by n plus 1. Look here, students, just write in the column integral x to the power n into dx is equal to x to the power n plus 1 by n plus 1. Okay, so in the place of x we have v, in the place of dx we have dv, in the place of n we have minus gamma. Okay, so will you try to write, students, how to write the solution of integral v to the power minus gamma into dv? So try to write. So here you can see, students, similarly integral v to the power minus gamma into dv is equal to, in the place of x we have v, so v to the power minus gamma plus 1 by minus gamma plus 1. This also you just write in the column. Okay, so now shall we write the next step? Okay, so look here, therefore w is equal to k into, students, inside the brackets now we have v to the power minus gamma plus 1 by minus gamma plus 1 within the limits v1 to v2. Okay, understood that step? So the same here we have written here. Now, next step, what did I do? Just look at the next step, students, here. Here we have minus gamma plus 1. Okay. So here what did I do? Just interchanged. Plus 1 I have written, minus gamma I have written here. So I changed it as 1 minus gamma. Is there anything wrong in that? No, right? So w is equal to k, next v to the power minus gamma plus 1 by 1 minus gamma within the limits v1 to v2. Written. Next what did I do, students? Look at the next step. This 1 minus gamma, I brought it outside the brackets. So here you can see w is equal to k upon 1 minus gamma. Now what remains inside the brackets? Don't write again inside the brackets 1 minus gamma. We brought it outside. So inside the brackets there will be v to the power minus gamma plus 1 within the limits v1 to v2. Write down. Okay. Now you all know that next step. So within the limits v1 to v2. So now in what happens inside the brackets? So v2 to the power minus gamma plus 1 minus v1 to the power minus gamma plus 1. So this is the next step here. W is equal to k by 1 minus gamma into v2 to the power minus gamma plus 1 minus v1 to the power minus gamma plus 1. Again now don't write the limits v1 to v2. Okay, written. Next. W is equal to, here it is 1. So what did I do, ma? I multiplied k with v2, k with v1. So here what should I write? I cannot leave it blank, right? So I can write it as 1. So 1 by 1 minus gamma into k into v2 to the power minus gamma plus 1 minus k into v1. So k v1 to the power minus gamma plus 1. So this is quite interesting, right? Look at the next step, students. W is equal to 1 by 1 minus gamma as it is I have written. But inside there is a simple logic. So we have v2 to the power minus gamma plus 1. That can be expanded like this. How? K into v2 to the power minus gamma into v2 to the power 1. Together it becomes v2 to the power minus gamma plus 1 only. Okay. So v2 to the power minus gamma plus 1, I expanded like this. Similarly, minus k into v1 to the power minus gamma into v1 to the power 1, which becomes completely as v1 to the power minus gamma plus 1, which is our previous step. Why did I do this? Because look at the next sentence. We know that PV power gamma is equal to constant, that we have taken it as k. Next, this can be shown or written as P1 V1 to the power gamma is equal to K and P2 V2 to the power gamma is equal to K. Okay, why? Because PV power gamma is equal to constant. That can be P1 V1 to the power gamma is equal to P2 V2 to the power gamma. So P1 V1 to the power gamma is equal to constant. P2 V2 to the power gamma is equal to constant. Now here P1 V1 to the power gamma is equal to K. From this equation, P1 would be equal to K divided by V1 to the power gamma. If it is taken to the numerator, then it becomes V1 to the power minus gamma. Similarly, you write for P2 also. Where from here, P2 is equal to K upon V2 to the power gamma, which is equal to K into V2 to the power minus gamma. Okay. So now look at this above equation. K into V2 to the power minus gamma. K into V2 to the power minus gamma is now P2. K into V1 to the power minus gamma is P1. Shall we substitute there, ma? Yes. W is equal to 1 by 1 minus gamma into P2 V2. Look here. This portion is P2, but V2 is there. So P2 V2 minus P1 V1. P1 V1. Okay. So which can also be written as, look at the next step. W is equal to P2 V2 minus P1 V1 divided by 1 minus gamma. So students, put it in a box. Okay. Now if you are given in terms of pressure and volume, we use this expression for work done. Okay. If you are given in terms of pressure and volume, we use this expression for work done. If it is given in terms of number of moles and temperature, then what to do? So write down below, students. We also know that PV is equal to nRT. What is PV is equal to nRT? Ideal gas equation for n moles of a gas is PV is equal to nRT. Okay, so write down. We also know that PV is equal to nRT, which can be taken as P1 V1 is equal to nRT1 and P2 V2 is equal to nRT2, where R is the gas constant, N is number of moles, T1 and T2, the two different temperatures. Okay. Now, so using or substituting these values in the above expression, we can write it as W is equal to 1 by 1 minus gamma. Now, P1 V1 is equal to nRT1, P2 V2 is equal to nRT2. Okay, so nRT2 minus nRT1. So, in both the terms we have nr common. So, bring nr common out. So, 1 by 1 minus gamma into nr into what remains inside the brackets? T2 minus T1. Therefore, W is equal to nr into T2 minus T1 by 1 minus gamma. Okay. So, if you are asked in terms of temperature and number of moles, then use this expression W is equal to. Okay. So, if you are asked in terms of pressure and volume, then you are supposed to use W is equal to P2 V2 minus P1 V1 by 1 minus gamma. Okay, students, hope I made this derivation clear and also easy for you. Please practice it once or twice. You will enjoy mathematics, students. Okay, so please write it down in your notebook and practice twice or thrice. I always say this in case of mathematical derivations. They are very easy and very much interesting. Okay, so draw a line till here. This is the expression for work done. by a gas in by an ideal gas in an adiabatic process. Okay, students. So thank you for watching, and meet you in the next video with a new topic.